In this video, I'm going to go over some examples of solving a system of linear equations using elimination. So in this first example, we see that we have a 5x and a minus 5x. So if we add the equations together, okay, I'm going to add them together, that is going to cancel out, and it's going to leave me with negative 6y plus 5y is equal to negative 1y or negative y, and negative 14 plus 15 is positive 1. Therefore, y itself is going to be opposite. It's going to be negative 1. So I know one of my variables. If I want to find the other, I now need to plug it back into one of the equations. So I'm going to take y equals negative 1, and I'm going to plug it back into either this one or this one. I'm going to choose this one, and I'm going to solve now for x. And the new equation that I get is going to be minus 5x, just copying that, plus, and now it's going to be 5 times negative 1. So I just put this value into here, and that's all equal to 15. Negative 5x minus 5 equals 15. And add 5 on both sides. Negative 5x equals 20. And if I divide both sides by negative 5, x itself will be negative 4. 20 over negative 5 is negative 4. Negative 5 goes into 20, negative 4 times. Therefore, I now have my x and y value. So I'm going to write it. My answer, the format of my answer is going to be an ordered pair. Remember, an ordered pair is x value followed by the y value. So in this particular case, it's going to be negative 4, my x value, followed by negative 1, my y value. So this is the solution to that system of equations. It makes simultaneously true. If I put it in, this will be true, and this will be true. Both equations will be true if I put in negative 4 for x and negative 1 for y. In this next example, we can't just add these together because nothing is going to cancel out. This will not cancel out with this. This doesn't cancel out with this. So I need to put it in a form where it will cancel out. In order to do so, I'm going to multiply everything by 3. Remember, if you multiply one thing by 3, each term needs to be multiplied by 3. So this now is going to be negative 9x, distributing across here, negative 9x plus 6y equals 30. And now I'm going to add the top equation with this new equation that I have. The top equation goes together with the new equation, and 2x minus 9x is minus 7x. And this minus 6y cancels out with this plus 6y. So now I get negative 7x is equal to 19 plus 30, which is 39. Excuse me, 49. So negative 7x is equal to 49. And now I'm almost there. Solve for x. I'm going to divide by negative 7. Divide by negative 7. So x itself is going to be negative 7. So now I've rewritten this equation, plugging in negative 7 for x. That will help me solve for y. So 2 times negative 7 is negative 14, minus 6y equals 19. I can add 14 on both sides. gives me 33. Divide both sides by -6. And y is going to equal -5.5. So I have my x, I have my y, therefore I have my solution. And the final form that I'm going to write it in is as an ordered pair. I get -7 for the x value and -5.5 for my y value. This ordered pair is a solution to both of those equations. The last thing I want to look at is a couple of special cases. You'll see that these are similar, but there's an important difference. So if I wanted to get these in a form that I could cancel them out, a good strategy might be to multiply the top by -2. And that would give me -8x. Okay, so my x's would theoretically cancel. Minus 6y minus 24. You'll notice when I multiply everything by 2, I just get the opposites of everything. And what happens there is the 8x and the -8x make 0. -6y and +6y make 0. And -24 and 24 make 0. So all I end up with is 0 plus 0 equals 0. That's because these two equations were actually equivalent equations. They're the same thing, just in a slightly different form. So when are they the same? Always. So this has what we call infinitely many solutions. Okay, so think about it. 0, when is 0 is equal to 0? It could be 0 when no matter what the value of x equals or y equals. 0 is always 0. Therefore, we have infinitely many solutions. Both lines, or both equations, both represent exactly the same thing. Now let's look at another variation on that. This one looks very similar, right? So I would approach this by multiplying the first one by -2. In this case, I get -8x minus 6y again. And on this side, I get -12. So you'll see what happens here if I add these guys. -8y and 8y is 0. -6y and 6y equals 0. And then I get -12 plus 24 equals 12. When does 0 equal 12? Never. it 0 is always equal to 0. 0 is never equal to 12. So these are kind of opposite cases in a way. This one, we would say, has no solution. If you get something like 0 equals a number other than 0, no solution. It's not possible. If you get something that's true all the time, like 0 equals 0, infinitely many solutions. So those are two of the special cases that you might encounter. You need to keep an eye out for it. And remember, they happen when you end up canceling both things out at the same time and getting two zeros on one side. Like in the previous cases, if you cancel it out and you still are left with one variable, then you're always going to have one solution. So those two special cases only arise in those weird scenarios where everything on the left side of the equation cancels out. Hopefully that helps. Keep on practicing. Thank you very much for your time and attention.